Hey guys, in this video we're looking at cyclic quadrilaterals. It's very simple and straightforward. We've kind of seen this theorem in a few videos past. So just really quickly, say angle A plus angle B should equal 180 degrees. Then we're looking at angle C plus angle D should equal 180 degrees. They are supplementary as well. And then if you really think about it, these two angles should be the same. So we could say that angle E is equal to angle B, okay? Because if A plus B is equal to 180, and these two angles together add up to 180, the common factor that they both have is E, or well, sorry, is A, and therefore E should equal B, okay? So we're going to apply this on the right hand side. We've got this shape here, and don't want you to be assuming that because it looks a certain way, then it is a certain way. But let's look at this. That's 90 degrees there, if this is 90 degrees. And because this is diagonally opposite to x, x plus 90 should equal 180, and it just so happens to be the same number. So x is equal to 90 degrees. We can call this w, okay? So w plus 120 should equal 180 degrees. Therefore, w is equal to 60. But the other way of looking at it is that this external angle is the same as what we were dealing with here with E, okay? So therefore, 120 is equal to y. There's no point in trying to work out what w is, because you can already see it from the external side of things that it's exactly the same value. And then we're going to finish off with this diagram. And these two angles in blue should equal each other. So reverting back to the cyclic quadrilateral theorem that we just covered before. So we can automatically say that 3x squared minus 5x minus 1 is, this is actually plus 1, is equal to 2x minus 1 minus 3x squared. So I'm going to add 3x squared to both sides. I'm going to add, let's just take this out. I'm going to add 1 to both sides, and I'm going to take away 2x from both sides. So we'll end up having 6x squared minus 7x, and I did say this was a plus 1, so then this is going to be plus 2 equals 0. What we have here is a non-monic expression, so I need to multiply 6 times 2, so 6 times 2 is equal to 12, and factors of 12 that add up to minus 7 is minus 3 and minus 4. Okay, so we got 6x squared minus 3x minus 4x plus 2 is equal to 0. We're going to then factorize by grouping. So remember, going back to quadrilaterals and quadratic equations and factorizing that, please revert back to those videos or to that chapter if you need to refresh your memories. What we have here is we've got we're grouping in halves, and we find the highest common factor, which is 3x. So we got 2x minus 1, and we always want the second set of brackets to be exactly the same. So in this case, we're going to have minus 2 as our highest common factor, because minus 2 times 2x gives us the minus 4x, and then minus 2 times minus 1 gives us the positive 2. If we make this positive 2, then we need to reverse these two polarities, and then the two brackets are going to be the same. So that equals 0. We've got 3x minus 2 as being the first brackets, and then 2x minus 1 is going to be the second brackets. Now we can apply the null factor law to work out what our values of x are. So we'll have 3x minus 2 is equal to 0. So we'll move this across 2. So we've got x is equal to 2/3. The other option is 2x minus 1 equals 0. and then we could have x is equaling a half. Okay, so you got those two options there as your answers for this equation. So 2/3 degree and half a degree. Great, guys. If you've got any questions, let me know. Otherwise, I'll see you in the next one.